Now let's shift gears and let's talk on our list of television and video attribution methods about one of the more common methods that you'll see in practice, because it's something that could be implemented by individual brands without having to partner with any other technology firms, and that is post-spot lift analysis, otherwise known as spike analysis in some cases. Let's discuss how it works, why it works, and where it goes wrong. All right, so let's do a plot here. So let's say that on the x-axis we have time. Y-axis we have some measure of users to your website. So generally you would use post-spot analysis when you're doing a direct drive to web campaign, direct response. You're trying to get people to come to your site in response to your television campaigns. Now let's say that your television ad starts over here in time. So this ad starts. Now, if your ad is sufficiently sized and your baseline of traffic is sufficiently small, what would we expect to see happen in your website traffic if in that ad you try and get folks to come to your site? So let's say your baseline of traffic is something like this. It might go up and down, up and down. The TV ad starts. So what do you expect to have happen? Well, at first, nothing, because it takes time for folks to recognize, hey, this ad is for this brand, is asking me to do this. They then have to take out their smartphone or a device to visit your site on, if they even do that. So there's a delay. Usually it's about 7 seconds. And then you're going to suddenly see this quick uptick of traffic. You're not going to see it with any one airing unless you're talking about Super Bowl level airings, or if your baseline of traffic is low. Usually you'll have to aggregate a bunch of spots together. But this is what you're going to see after when you group them together. And you're going to then see the traffic will then start declining, and it'll exponentially decay out and then return to the baseline. Sometimes it's 10 minutes after, sometimes 15 minutes after, sometimes it could be as short as 1 or 2 minutes after the airing started. We call this, or I call this, a bi-exponential curve. It's two exponential curves that are put together, one with a very rapid increase in traffic and then a slower decline back to baseline. And this is in response to people coming to your site in response directly to your ad. And then as more and more folks come in, they're spread out over time. And so that's why you see this tailing off effect going back down to the baseline. All right, so where does the data come from in order to create this type of plot to measure this increase in traffic? So there's two sources of data. So the first is the television post logs. These are the logs that you're entitled to when you purchase TV that say when your spots aired. So there's going to be some type of timestamp. There's going to be the network that it aired on and some other information. And then these dots here, or the users, are coming from your own site logs, whether these are server logs or even something like a Google Analytics. Either way, there's going to be some type of a timestamp in there as well. And you're going to then do some type of a join between the site logs and the post logs using time as at least one component in the key. All right, and what's cool about this method is that because of its proximity to the airing of the ad, and because you can see what your baseline is, any of the lift that you measure after these airings that kind of where you could clearly see this bi-exponential curve, you could be pretty sure is caused by the ad. Again, due to proximity of time, the fact that it has this very distinctive curve that we know is I call it the TV curve, and because we've controlled for the baseline. So the causality is essentially established. You know, we're ignoring the fact that we're only measuring a small sample of those that are impacted by TV, and it may very well be a biased sample. But for that group that we did measure, it's causal. And that's cool, because a lot of other methods are correlations, not causality. Here's the problem, though. A lot goes wrong. In order to get to this step here, in order to get to this visual, a lot of things have to go right on the technology side in order to get to this. So let's first talk about time, since we were already talking about the join. The timestamps have to be accurate in the post logs. It's surprisingly difficult to get to that point. It has to be accurate at least down to the minute level. Preferably, if we have a very large baseline of traffic, you need something that's even lower granularity, down to the second level, plus or minus maybe 3 seconds, 5 seconds or so. So you need the timestamps to be accurate. You also need them to be in the same time zone as whatever the traffic logs are that you're using. And of course, you need your traffic logs to be accurate so that you can then do that join. Here's where things tend to really become problematic with time. So time zones very quickly become an issue. But above and beyond just time zone issues and making sure that these stay synchronized, you have, in many countries, you have a concept of multiple feeds. US is a two-feed country, meaning there's an East Coast feed and a West Coast feed. Here's the way it works. For a percentage of networks, the majority of networks, they run on what's called a single feed, meaning that the television, your ad, is going to run at the same UTC, the same chronological time across the country, regardless of time zone, which means that when you look at the local time, it's going to be offset. So say if it ran 8 p.m. Eastern time, it's going to be offset by 3 hours from West Coast time. So West Coast is earlier, so 5 p.m. here, meaning that the UTC is the same. The spot aired at the same chronological time, so it ran once, it's single feed. But then you have a set of networks, and it's not a small number of networks, where they're going to run at different UTC times. So essentially they're running at the same time in their local time, so 8 p.m. Eastern and 8 p.m. West Coast Pacific time, which means that they're going to be off by 3 hours, roughly. This is called dual feed because the ad literally had to run 2 separate times on those different time zones. Now, guess what? In order to then correctly do this join, you need to figure out which networks are dual feed and which are single feed. And in the case of dual feed, where there was 2 separate airings, they're only going to appear as one entry in the post log. So the way you usually solve this is you need to create your own synthetic record for the West Coast feed. But it gets tricky because then you need to know, well, how many impressions happened on the East Coast, how many impressions happened on the West Coast, so that you could combine them correctly and join them correctly with the post logs. So that's where a lot of things could go wrong. But we're just looking at time. There's more complexity than time because then we also have the geo or the DMA in TV speak. So I've assumed in this and everything we've talked about so far that this is a national television campaign. But what happens if you're doing local television ads? Or what happens if you're stitching together and you're running ads in a bunch of specific DMAs and kind of stitching together a national campaign using local airings through the local DMAs? Well, in that case, now not only do I have to do a join keyed on time, I have to include the geo as part of the key, meaning that I'm only going to be getting lift in certain parts of the country at certain times. And so now you also need to synchronize the geographic locations between your post logs and your site logs. And so usually the way we'll do that is we need to figure out what's the DMA for different traffic on our post logs coming in. And so you may have like the IP address for the user. You'll then have to figure out how do I map that IP address to the DMA market that they're in, so that then I know the geo that I should be looking for when a particular airing happens. Now let's take a step back because we're getting into the technical weeds here. There's a bigger problem here, which is who is in this, like what percentage of our total lift is actually appearing here? It certainly is a small subset because it's only the subset that responds immediately after the airing occurs. So that's a big problem. We're going to have to scale this up in some way, but it may not be as trivial as just putting a multiplier on this. Like say if we can measure that this might represent only 5% or 10% or 50% of the total television response, can we just double it and say, all right, well, that captures everyone else that would have come in afterwards? Not necessarily, because also we have an issue of bias. The people that respond immediately after the ad aren't they different than everyone else? Probably, because it means that they had a smartphone on them or some type of device that they could respond to right away. It also means they're fast. I mean, imagine responding to something 7 seconds after the airing. You had to have recognized the ad, recognized the brand, taken out your phone, entered it in quickly. So the folks that come in here tend to be younger, tend to be more educated in many cases, tend to be higher income. But it gets even stranger because remember, everyone that we're looking at here is watching time on a this only works with linear TV, meaning that it relies on the fact that a bunch of people are watching that at the same time in order for us to be able to see that lift. So linear TV only. If there's any type of time shifting, meaning if someone has DVR'd it, or if we're talking about Hulu or Netflix or any type of OTT, this does not work. You have to have a bunch of people watching the ad at the same time in order to be able to measure these. And so everyone that falls in here is going to basically skew to be older populations for the most part, because older populations are generally the ones that are mostly watching broadcast cable TV, while younger generations tend to be going on OTT like Hulu, Netflix, and online services. So we have a bias where everyone that we can measure with this system is probably skewing older, but then the folks that are coming in just on this bump probably are the younger part of that older skewing bias population. So it's a mess. It is really a mess. And there's a lot more I could go into here. There's a lot more problems in a white paper. I go into gory detail of all of the issues, but this is just some of the problems. Now, that being said, is there any utility to doing this at all? The answer is yes, because it turns out that it solves, first off, a bunch of the litmus test problems. Number one, the lift curves will correlate with our spend. When we increase our spend, you're going to see a corresponding increase in lift, assuming it's a traditional national campaign that's running on linear television. When you turn off TV, or if you're looking in geos where you're not running TV, you're not going to see lift. This assumes that you've controlled for the baseline. So I haven't even gotten into the baseline controlling, which is a big piece of this. But let's say that you've controlled for the baseline and you've computed that I would have expected this had there been no TV, and instead I saw this breakout. As long as you're controlling for that, you should see zero lift if you're doing this correctly when there's no television running. By exponential lift curve. In fact, this is the way that we could validate that technically we've done the joins correctly. It takes a lot of things going right to see that curve emerge. So if you see that, the joins for the most part are there's no major issues with those joins. Here's where this method struggles. Capturing the whole truth. No, it doesn't capture the whole truth. It's capturing an unknown percentage of the truth, and it's a biased percentage of an older population on linear TV, but then we're doing a subset of the younger folks within that older population that we're measuring, because it had to be the folks that could whip out their iPhones fast enough, and they had the technology to respond quick enough to be in this loop. So I said, though, that it has utility. The reason why it has utility is it turns out that, first off, using smart TV data, there are ways that you could calibrate what percentage of the total lift you're measuring. In fact, you don't even need smart TV data. If you do a correctly designed survey, you could actually figure out what is that a good multiplier to put onto this. And now with the issue of bias, this is where it gets trickier and more nuanced. We have to understand what your product is, because it may be that the bias is irrelevant and it doesn't matter that this is a younger population or an older linear population. So it really then comes down to what is it that we're trying to sell. What I found in practice is that if you're doing this correctly with the correct controls, what you see working with post-spot lift analysis will correlate roughly 70 to 80% with what is working when you're looking at smart TV, which to me is the gold standard for measuring, because it's a direct down the funnel attribution. Meaning that if I see network XYZ working better using post-spot lift on the smart TV data, we're also going to see that network XYZ is ranking up high. And that should give you, that corroborating evidence should give you confidence that, hey, multiple methods are aligning here. I can feel good about the measurement. So it's not that there isn't issues, but it still has utility. But what I'd like to just point out, though, is it doesn't interfere with user experience. You're not breaching privacy. You're using your own site log data and your post logs that contain when your airings occurred. You could do this work. You could do these joins in-house, so you don't rely on anyone else. And so for that reason, it's worth doing. Just also be aware, though, it's something that's going to become less useful over time as linear TV starts going away. As more and more folks switch to using online services, you're going to see that lift is going to, that curve is going to go down, go down, go down until eventually, if everyone's watching TV at different times, this is just going to be zero. So eventually it's going to stop working. But for now, it still has utility. And for that reason, why not include it as part of your arsenal of tools to measure television? Hope this has been helpful.